almost doesn't sound like a frog. Sounds like some sort of small dabbling duck or something.
Or a goose.
Yeah.
Yeah, well, we're guessing the amphibian here, Ben. It's your turn to guess.
I think someone would give it a name that would hint that it's bird-like trickery.
Yeah, well, don't get confused by the bird that is also present in the... You can tell the difference, I'm sure. But there is a bird in there as well. That's the animal that we're in question. And then later on, there's like a bird that comes in.
I can't say I heard the bird. Oh, yeah, that one.
Yeah. So
oh, wait a second.
You probably realise that's not
Oh, wait a second, but the bird might help me separate out geography.
If you identify the bird, that's cheating.
That's tricky.
Yeah, I think it's a big ask.
All right. Oh my gosh, is it...
Do you want a clue?
I reckon you've... Yeah, I'd love a clue.
Okay, well... It's from the area that we're talking about today.
Yeah.
Yeah, so we're West Coast USA here.
The Californian marsh frog.
Just so close, mate. It's the Californian toad.
Californian toad.
California toad. Yes.
So what's that? Bufo californiensis?
No, it's Anaxyrus boreas.
Ah, a boreal toad.
Boreal, yeah, as in
lover of large trees.
Yes, but also a lover of
trees.
Is it cold trees, boreal?
Right.
I don't know. Anyway, they love most habitats. They're habitat generalists. So yeah, they are found in forests. Right. So I could see them being named that because of boreal is like, it's like a chilly woodland, isn't it?
Of or relating to the north, of or concerning the north wind. Of or relating to forest areas of the northern temperate zone.
Right, okay. So yeah, further north. There's a proxy for coldness.
Yeah. So a hardy toad.
But that call you heard, that... It's actually not an advertisement call, so females would not be interested in that call. They wouldn't recognise it as something which was designed to tempt them in.
Okay.
No, they are in fact competitive calls. They make that noise when they encounter another male. So that is a male toad, a little bit...
A battle cry.
Yeah, kind of a battle cry. More, yeah, just like a sort of, hey, this is my zone. Get out of here. Like, check out how badass I am.
Yeah.
They don't have a specific advertisement call to try and lure in females. They do have another type of call, though, which I'd never actually heard of before, I must confess. Have you ever heard of a release call?
No.
So a release call is apparently quite a common thing that a lot of frogs and toads have. I mean, maybe some salamanders have it. I don't know. But it's called a release call. And essentially, like, this isn't a species which is explosive breeding, right? So they're getting very carried away in the pools. They're all breeding at once. They've come out. And it's a big day. And so they're all grabbing onto each other, particularly the males. And apparently, if a male grabs another toad which is not receptive, and it could be not receptive because it's a male, it could be non-receptive because it's a female who's already mated. Yep. It could be non-receptive because the female is just not feeling it.
Yep.
All these possible reasons. But yeah, they make this special noise which
get off.
Tells the other toads, get off me. I'm not what you want to mate with. This isn't worth your time. Which is great. Like, I would imagine it's probably a signal that's quite honest, like, don't waste your time, get off me. But apparently also, if you pick up a Californian toad and like, squeeze it gently, it will sometimes elicit the noise of being
get off me.
Inappropriately grabbed. Yeah. So not that anyone should be squeezing their local amphibians, but it's quite an interesting...
that is interesting.
Little... Just funny that you can trigger that behaviour. Just like being squeezed by anyone or anything, it's like...
Get off.
Instigates that reaction.
There we go.
But yeah, This is a toad, a warty toad from California. Like I said, pretty general habitat. They'll do whatever. They're pretty tolerant. They're an invasive species in Hawaii. I think they were released there to eat bugs or something stupid like that. I don't know why we're still doing stuff like that. Probably not. It's probably a while ago. But
it better be.
They're not hoppers. They're walkers.
Well, that's classic toad, isn't it?
Yeah.
They're little cruisers.
Yeah, I rate that. I think, well, yeah, don't hop, walk. It's much more dignified. So they're also nocturnal. At lower elevations, they're nocturnal, but at high elevations, they become diurnal. So they're active at night at low elevations, and then at higher elevations, presumably it's too cold to be active at night, so they become active in the day. So, they're a pretty easygoing, flexible species in terms of behavior.
Excellent.
But yeah, that was the call. You didn't get it right, so it's still 2-2 overall.
It's up to you to keep count, mate.
I'm keeping count, and it's 2-2, I think.
Okay.
I think so. Yeah. Yeah, so the reason I chose the California toad is because the paper that we're talking about today takes place largely in California. It's also about a toxic amphibian. These toads, of course, like many, many toads, have the parotid glands on their neck, which produce a toxin. So
don't bite them.
Don't bite them. The connection is toxicity and location. And let's get into our paper. So this one is by Gilbert, Cabrera, Hague, Stokes, Feldman, Hanifin, Brodie and Brodie, 2023. Phenotypic outcomes of predator-prey coevolution are predicted by landscape variation in climate and community composition, published in Functional Ecology. So,
classic example. Like the classic example that people go to. You open the book and you look up the evolutionary arms race, and there'll be a big picture of one of these salamanders staring you dead in the face. You'll be like, I'm not touching that. And you'd be right.
Yeah. They call it a newt rather than a salamander, don't they? I don't know where newts end and salamanders
potato,
begin.
right?
I think so, yeah. I'm never too sure. But yeah, you're totally right. It is the textbook
There's
example.
like true salamanders of like Salamandra, right?
Yeah.
But common names are all a bit shaky, aren't they? It's all right.
I don't know why I even mentioned it, mate, to be honest, because I don't,
You just want to start a fight.
Yeah, you got one, buddy. So yeah, so these newts, these snakes, live in the same area. The newts are toxic to the snakes, and like you say, this has triggered evolutionary arms race with newts trying to evolve more effective toxins. But yeah, the whole point of this research was to kind of understand nuances of this arms race, because toxin evolution isn't just tied to the sort of resistance of any potential predators. And this idea that there's kind of geographic variation in the toxicity of the prey and the resistance of the predators. And this sort of idea has a really good name. It's called the geographic mosaic theory of coevolution. But yeah, essentially the idea is that these different species can gain a resistance, and at the same time, newts are trying to become toxic. So the snakes are the predators in this
I was going to say, who are these snakes? Who are these potentially resistant, potentially not resistant snakes that are fool enough to consume a toxic newt?
Yeah, the group is garter snakes. The main one is the common garter snake, Thamnophis sirtalis, but we do mention a few other snakes later on. And, they're able to evolve this sort of resistance to the toxin, and the toxin is coming from a newt, the rough-skinned newt. So the scientific name for the rough-skinned newt is Taricha granulosa. Taricha actually apparently means preserved mummy, which refers to its rough-skinned appearance, which is pretty mental.
Just like a mummy, and more toxic than a mummy.
If you said to me, like, what is the defining characteristic of a mummy, I wouldn't say the rough-skinned appearance. I'd probably say the smell.
Have you ever smelt a mummy?
No, but I imagine they
operating on ignorance then. Okay, case closed. Let's move on.
When you thought a mummy would hum? Come on, man. It's like a decomposing corpse wrapped in bandages and left in a hole for 10,000 years.
I would suspect that actually the smell is the least of the concerns, because smell tends to be connected to rot and stuff, and mummies are specifically anti-rot, are they not?
Well, yeah, but mate, if you get up close to one, I reckon it's going to have a little bit of smell.
But I reckon it smells more preservatives than anything too bad.
Maybe you're right. But anyway,
Salt.
So yeah, they're named Taricha, the genus, means preserved mummy, and granulosa, which is the species name, that derives from two Latin words, granulus and osus. Granulus means small grained, osus means full. So this individual species is full of small grains, and this refers to the rough-looking glands that cover the newt's body, giving it the common name rough-skinned newt.
There you go. You prefer that one,
glands,
right?
Yeah,
as opposed to the mummy comparison.
That's perfect.
There we go.
But yeah, this newt is toxic. This whole group in the genus Taricha is toxic. They contain this Tetrodotoxin, which is a potent neurotoxin. It inhibits the movement of sodium ions across cellular membranes, kind of similar to the toad toxins, actually, from the California toad. And these lead to,
Similar,
although I
but
think
different.
these are
Yeah.
similar, these are much more potent, right, as well.
Well, and I assume the Californian toads aren't tetrodotoxins, but I do think they're acting on a very similar area
Yeah.
with the whole
No, they're
sodium channel
bufotoxins,
thing, right?
Yeah, that's what I'm saying. Yeah, different
Yeah.
toxin, but similar action.
Yes.
So if you ingest these tetrodotoxin from the newts, you'll become immobilized, and then you'll be in respiratory distress, and then you'll be paralyzed. This is an amphibian. We had a species recently that people were licking recreationally. This is not one that people are going to lick recreationally or for any reason, unless they're mad, because if you lick one of these, you will die. Tetrodotoxin is one of the most toxic substances known. The lethal dose is 275 times less that of cyanide. So yeah,
Whoa.
It's pretty deadly. Pretty deadly. Yeah, don't muck about with it.
Okay.
It's the same stuff that pufferfish have in the famous toxic Japanese dish fugu.
Ah.
Yeah. And it's interesting because these newts, obviously, on some level, they've evolved being toxic, and they exhibit the Unken reflex. You know, that like funny little move where they like touch they roll backwards and touch their head against their tail.
Yes.
The Unken reflex. And they have really bright orange bellies. On top, they're kind of grey-brown, but underneath, they're bright orange. And that is obviously a warning. It's a signal to say, hey, I'm toxic. I wouldn't be doing this crazy thing instead of running away if I wasn't toxic.
Aposematism.
So,
Classic.
exactly. And so because of this toxicity, snakes generally can't eat them, but garter snakes have evolved a resistance mechanism within their cellular potassium pumps. That means they can resist the toxin, but they can't just like universally resist it. They can resist like some amount of it. So there was this study which showed that there was a threshold of toxicity that the snakes could handle, and they seemed to be able to tell how toxic a newt was by handling it with their mouths. So garter snakes would pick up a newt, and they're more likely to drop them the higher the toxicity on that individual newt's skin. And so this study was kind of designed to build on that.
It is very much a resistance, not an immunity.
Absolutely, yes. They probably feel a bit tingly and weird when they eat them. Apparently that's the thing. If you eat the fugu pufferfish, like some chefs, some like gourmet chefs, because in the fugu pufferfish, it's in the skin, but also in the liver, and I think the ovaries also has it in. These like skilled chefs in Japan will like take all the skin off, take all the entrails out, and they'll serve you like the pure meat, which is like unadulterated with any of this tetrodotoxin. But apparently there are some chefs who like, you know, they're sort of like living on the edge chefs, the sort of the back alley guys, and they will actually give you like a fish which has a very, very small amount of the toxin present, so that when you eat it, you get a little tingly lip sensation. It makes you feel a bit silly, a bit dangerous.
Right. It means your lips are going numb because your nerve endings are being blocked.
Yeah, basically, just try it out. Just a little taste.
Nah, man.
Which seems absolutely insane. But yeah, I think the impression I got from the short YouTube video I watched was that that's like not done by the sort of top quality
Not by the
chefs.
pros.
They frown on that. It's only the back alley guys who are like, hey, how about a little toxin? Which seems like a terrible shout for something which is 275 times more deadly than cyanide. Like, get it away. I wouldn't even eat it. Yeah. I mean, I don't eat fish anyway, but I wouldn't eat this. No way. Even if I caught it myself, I wouldn't eat that. No way. Not worth the risk. And especially as like, I mean, maybe it's delicious. It's eaten raw. It just doesn't seem good enough.
It does seem worth the risk.
It does not seem worth the risk. Yeah, exactly. This study that we're talking about is building on this knowledge that we already have about this interrelationship between the toxicity of the newts and the resistance of the snakes. And so they were looking at newts and snakes from across the whole area that they overlap, testing the toxicity of the newts and the resistance of the snakes to the toxin. And kind of broadly speaking, as you'd expect, they found that in areas with greater snake resistance, the newts were more toxic, suggesting that this arms race is in action. And they had a map, didn't they, showing the areas. I don't know where you want to go. If you want to go map, if you want to go elsewhere.
I want to do two things. One, I want to highlight, before we go any further, just how they worked out how much resistance a snake had. And that was testing them by sending them down a racetrack to see how fast they could move. Because the whole thing is with this toxin affecting like muscle stuff. Basically, if you're under the influence of this toxin, you're not going to be moving as well. So that's how they worked out. There were different studies done in different places trying to see how resistant the snakes are, and that's how they did it, was testing them. How fast can you go normally? How fast can you go when you're given a certain dosage of toxin? Which is kind of, I don't know, I find that quite interesting, just seeing how fast snakes can go as a proxy for that.
Yeah. That's a wild idea.
The other thing makes this whole study sort of more complicated from a stats point of view and sort of from an understanding point of view is all their sampling locations for the newts and all their sampling locations for the snakes are different. There are very few that are paired one-to-one. So it's not like a straight comparison of here we are at site A, we have snake and newt, how do their resistance, toxin, and other variables compare? It's, well, we have a snake from valley over there and a newt from where we are here, and they're about 10 kilometers different. We can't compare them exactly, but also everything's a bit sort of mixed up and there's no one-to-ones, or very few one-to-one comparisons. So, jumping onto the map, like you mentioned, they've sort of made a heat map for both of these variables, both of these sort of instances of where the newts are toxic and where the snakes are resistant. And then they're comparing those sort of heat maps together to work out whether there's this sort of congruence in toxicity and snake resistance.
Yeah, and there kind of is, right? It's not like one-to-one.
But it's pretty... It's
There's
there.
a general
It seems
pattern.
there. Yeah.
Yeah, it would also be easier to work out how close it is if the maps were the same or like size. There's one zoomed in and one not, which makes it slightly confusing.
Yeah, visually, yeah. They have the plot, which sort of shows this positive relationship between resistance and toxicity. I mean, it's there. It's definitely there.
Oh, yeah. The relationship's 100% definitely there, yeah. The map slightly bamboozled me for a little while. But yeah, it's still cool. It's nice to have things visually presented. It's just like when you change how big is how zoomed in you are, I struggle. But yeah, the relationship's definitely there, and it's really cool to see. And I mean, you really can't fault their sampling. It is pretty broad, particularly of the snake resistance. They really did well, got a lot of samples from across the range. So yeah, kudos. They also talked a bit about the impact of climate, right? Which I thought was kind of interesting.
Yeah. This is a sort of added complexity to this, is that you were mentioning at the beginning that you've got these things like resistance and toxicity that are not necessarily just influenced by the presence and sort of predator-prey interactions of certain species. You know, they interact with the environment in different ways and presumably also come with different costs to maintain. Like if you're not having these snakes sort of bearing down on you with some level of resistance, well, maybe you don't need to be as resistant, so that pressure relaxes. But potentially other pressures can come from climate. Or what was the other thing they were looking at? Mostly climate, right?
Climate, but also other species, right?
Other species.
So where there were more species of snake that might eat the newts, where there were more species of garter snake, the newts were more toxic. And where there were more species of newt available to eat, the snakes were more likely to have a resistance to the toxins. So like where there's this impetus, be it because there's lots of different predators or because there's lots of different prey, that you know, that will force up one or the other. The other thing they talked a little bit about in regards to climate was this effect of reduced seasonality.
Yes.
So we've got two species here, newts and snakes, that are both ectotherms, so they are not producing their own heat. They're obviously going to be severely limited by temperature. They have quite narrow activity windows that they can actually tolerate in terms of temperature. And so if you have reduced seasonality, so less harsh winters and milder summers, or at least just less differences between summer and winter, this can increase how long the active periods are for these two species. And if they both have longer active periods, they're going to sort of be out and about for more of the same time, and that can lead to increased interactions, and that can drive an escalation in the arms race, which is quite cool. And it's interesting to think about that kind of thing.
Yeah, so it's climate not necessarily driving the sort of toxicity or resistance directly, but via this probability of encounter between the two of them, right?
Yeah,
like that's the idea.
Yeah, exactly. That is broadly their phenology, isn't it? It's like when the different things are happening to the animals in the year, like coming out of hibernation is part of phenology, going back into hibernation is part of phenology.
So they were suggesting weaker seasonality leading to more consistent sort of running into each other and heightened predator-prey and therefore heightened toxicity.
Basically, yeah.
I'm just wondering if there's a potential for something weird and non-linear happening. Because I wonder whether it's not necessarily the weakness of seasonality that leads to it, but more the overlap between active seasons. Because you could imagine a scenario where you had very, very tight seasonality and both species had a very tight window to get stuff done. And if that overlapped perfectly, well, it might be the case that snakes only have a very limited source of prey, that being the newts, that were also very active, and that could really drive it up. And obviously in this case it's looking like weakened seasonality leads to greater overlap, but I do wonder whether there could be a scenario where heightened seasonality sort of forces them into the same narrow window where everyone has to be really active, and it's just this sort of boom and bust situation, so you've got really, really high pressure for a really, really short period of time.
That could totally happen with other species, but I think with these two species, when it's tightened up, the newts tend to be active a bit before the snakes.
Right, so it leads to this desync in the active, in when they're active in seasonality,
Yeah, I mean, this is definitely something which is changing as well. Like, climate change is changing a lot of the sort of like emergence times and activity times. So yeah, it could be that changing climate has an impact on this as well, because it does affect a lot of species interactions via when they're active. So yeah, it's definitely an interesting case, but yeah, it's not just the interaction with the other animals, it's also the environment itself, which is quite cool. And I think that's kind of what's cool about this paper, is that they make an effort to try and unpick those things.
Yeah. I'd love to see the overlap in seasonality. That's what I want. Like, I almost want to change. I mean, obviously, integrating the climate stuff into the model was great and was needed, because that's how you get to these questions. But I would like the next step I'd like to see is like activity overlap driving toxicity. They mention it in the discussion. It's like, this is where this should go next, is a greater exploration of these interactions, but also like spatial ecology stuff for these guys, because activity is one thing, but activity is not like uniform. It's not like snakes get up and off they go day in, day out doing the same thing. You know, you've tracked snakes. You know how they act over a season. It's not just, it is active season, we must forage. So
yeah, it's a lot of nothing.
Right, it's a lot of nothing.
Yeah.
There must be moments that they're going to bump into these other species, because, I mean, these guys can't be... I imagine they're not too different from what you're tracking, really.
No, yeah, probably not a diurnal active foraging predator. Yeah.
Right?
So, one last thing I wanted to mention that's cool about these newts and their tetrodotoxin is this species lay eggs in water, and these hatch into larvae. And when they're larvae, they're already toxic. And it's not because they produce their own toxin. It's because the mother invests a little bit of toxin in each of the eggs.
Keep them safe.
Yeah, and apparently it keeps them safe not only from predators in the sort of normal sense of things that would eat them, but also it likely provides protection against some parasite infections.
Yep.
Apparently there's a bunch of like trematode flatworms that are internal parasites, and the toxin is known to be fatal to them. So yeah, there's this cool study by Calhoun et al. Where they just looked at like the toxicity of these skin secretions on loads of different parasites that are known to parasitize the newts, and like on quite a lot of them this stuff killed them. So yeah, pretty cool little twist that it's not just helping them as adults fend off predators in the form of snakes, but also it could be fending off little tiny parasites even when they're juveniles.
So another cool aspect that might be driving up that toxicity isn't necessarily predator pressure, but like a sort of parasite load as well. I think this is what makes these studies so interesting, is it starts drawing into all these different things that could be having an effect and trying to work out which one sort of has the biggest effect or which one sort of tallies up the most perfectly. Because they're all going to be mixed in there, but it's about sort of seeing their relative impact that's really interesting.
Yeah, that paper about the exposure of parasites, they called it Noxious Newts and Their Natural Enemies.
Noxious Newts.
I like that.
Yeah.
But yeah, fun little newt. I mean, the fact that they've got bright orange bellies is really cool. Apparently, if you pick one up, you really have to wash your hands. Like, as we've discussed, their excretions are not good for you.
I would probably not pick one up.
You wouldn't at all? You wouldn't pick one up?
I would need a very good reason to.
Yeah.
And I'd kind of want gloves.
Yeah, it does seem pretty bold. There's quite a few videos on YouTube of people just handling them. Yeah. The ramifications of handling them and then licking your fingers or touching your face are probably pretty high.
Yeah. And with such tiny dosages being dangerous, no thank you.
Yeah. Yeah, it's mental. So there we go. I think that pretty much concludes our episode on the toxicity of newts. So we had a toxic toad and then some toxic newts.
And a cool snake that can eat them. I can't wait for more stuff to come out of this like study system, because it's just infinitely fascinating, and I think this paper's a wonderful little like kickstart into something more nuanced in terms of activity and overlap, which I'd love to see explored more.
It's really wet the whistle.
Yeah.
All right, cool. So have you got any other business this week?
I do not have any other business this week, I'm afraid.
No, I haven't really got any other business. Not much has happened over the last week. Yeah. Had a couple of grant rejections, but that's science.
Oh, lovely.
Yeah. Had a big one this morning. I was like, oh, damn. But oh well. You can always use the ideas for something else, can't you?
Presumably, unless they were bad ideas and you were wrong to try.
Yes, well, could have been that. Yeah, no, I don't think it was that. I back the ideas. Yeah, some of it was tracking snakes, which would have been sweet, but we're onwards and upwards.
Can't be having that funded. Nah.
I know. It's too good. So, yeah, if you want to get in touch with us, you can. herphighlights@gmail.com. If you'd like to become our Patreon, patreon.com/herphighlights. And yeah, get in touch if we said anything wrong or if you want to ask a question. We're on social media. But yeah, otherwise, thank you for listening.
Yeah, thanks for listening.